Okay, so we saw in the last video the formula for integration by parts. Okay, and the good news is you don't need to memorize the approach, okay, how we actually got to it. Okay, and we got to it from the product rule. You don't need to remember that process, okay. It's just sort of some good insight to understand that it actually relates to the product rule of differentiation, okay, because we're now doing the opposite process. We're integrating a product, okay. And so the good news is, as I said, you don't need to remember this process. You won't have to repeat it in the exam, but also this gets given to you, okay. And just to prove that, on page 7 in the formula booklet, okay, you can see right at the very bottom, okay, it doesn't say integration by parts, that's not there, but it's clearly here, okay. It's exactly as how I derived it here, okay. So it's in the exact same format there, so don't remember it, just always refer to it in the formula booklet, okay, in that format there. So let me show you how we go about using it, okay. So let's look at first example. So number 1, okay, we've got the integral, okay, of the product x bracket x minus 2 to the power 4 with respect to x, okay. Now at this point, what I'd encourage you to do, okay, is to get that formula in front of you from the formula booklet there and take note of what we've got here on the left hand side. This will sort of represent your question, okay, so you need to sort of match it up with what I've written here, okay. So in other words, the first letter you've got there is U, so that will be representing my first term here, which is just the letter x, okay. The next term I've got in this integral is dv dx, so this term here will be my dv dx, okay. So it's kind of good, useful to just, in exam situation, every question you do, you have this in front of you and you just match them up, okay. So this is u and this is dv dx, okay, and of course you've got with respect to x there at the end, which is what I've got here, okay. So that's all you do for the minute in regards to the formula, right. So let's put that to one side. Now the next step you do is you actually then state underneath then what u is equal to and what dv dx is equal to. So u is equal to the first term here, which is x, and dv dx is equal to this bracket here to the power 4. Okay. Now the next step from here, now that you've got u, you need to work out what du dx is. Okay. So u is equal to x, so du dx will write underneath. So you just got to differentiate this with respect to x. Really easy, yeah? X just becomes 1 when you differentiate it. With this one though, we've got dv dx, okay? We've got the derivative. What we need now is the actual function for v, okay? So we can actually need to work that out, okay? So if we know dv dx is this, to work out v, we've got to integrate it, haven't we? Okay? This is the derivative, so we've got to integrate it back. So we've got to integrate this. Now think about how we would integrate this, okay? Work from earlier in the year. And quite simply, when you've got a bracket to power, and there's a linear term in there, it's linear because it's just an x term, okay? There's no x squared or anything. Okay, so you just got that. So when we've got a bracket to the power 4, remember what you do is you integrate the bracket first, yeah? So remember you add 1 to the power there, so 4, if you add 1 it becomes 5. And then you divide by that new power, which is 5. And you times it by the derivative in there, which is just going to be 1 in this case. Okay, so we get x minus 2 to the power 5 all over, well 5 times 1 is just 5. Is that okay? So you've done those steps there. What we do now is we go back to the formula, okay? So I'm going to write it down, Okay, you don't have to write it down, but it's kind of useful as you sort of get used to the process. So u dv dx dx equals uv, take away the integral of v du dx with respect to x. So notice I'm just copying, right? I haven't remembered it. I just copy it down. So now, remember now, this is actually your question up here, yeah? Okay, so yeah, your u was equal to x, and your dv dx is equal to that. So underneath now, I'm going to actually write my question with respect to x. So then you put it into the formula that we've got here, uv. So that means u times v. So u is equal to x, and you times it by v, which is equal to this. Then it says to take away the integral, and the integral is v times du dx. Now v is just this, times du dx. Du dx is just 1, isn't it? So if I times that by 1, well, I get that. And what's great is, well, that times 1 is just going to be this. It's just going to be the bracket about 5 over 5. And what's good then is I can actually integrate this. I can integrate this easily, because what happens is when you've got a bracket, just as we had before, to the power 5, well, I raise it by 1. So that'll be x minus 2 to the power 6. Divide by that new power, which is 6. Okay. Not forgetting there's a 5 there as well. So I've got to times by that 5. Okay. And obviously times by the derivative in there, which is just 1. Don't forget then you add a constant on. Okay. So I get my final answer to be x minus 2 to the power 5 over 5 minus x minus 2 to the power 6 over 30 plus my constant c. And I've integrated it. There is my final result here. Okay, don't forget to put the constant of integration in, because there's no limit. It's an indefinite integral. So you get used to this. It's not a difficult process. Okay, just a few steps and you get to the answer.